All right. I guess I'm just making this little video for you, Talon. Hopefully, help you out since I'm going to be busy tomorrow for your test. Yeah, it's a shame the internet went out, but it is what it is. So I guess the thing I wanted to start with was I wanted to ask you how you were taught. So let's pull up the problems. I wanted to ask sort of how you were taught to solve these sorts of problems because there's a lot of different ways you could go about it, and what works for my brain might not work for your brain. Everybody's brain kind of works differently how to tackle these. So I wanted to go over them, and I wanted to ask like how comfortable are you on these, like how um, in what level of detail do I need to break it down. So without knowing that, I guess I'll just sort of explain how I would go about solving them. Like, I don't want to do all of your homework for you. Like, I don't want to just give you the answers, but I want you to be able to learn and understand how to solve it yourself. So I guess just let me know if things don't make sense here. But so when I looked these over, it kind of looked like there was kind of a couple main concepts in these questions. So maybe these are topics that you've went over and you've learned. So, sort of converting between decimals and fractions seems like they could be an important part of these problems. And then percentages, the concept of a percentage, sort of as a fraction of a whole, like a certain um, amount, quantity of a total. So, then another concept I thought was ratios. There's sort of like relationships and equivalency questions, and then finally there's unit conversion type stuff at the end. So those sort of all play into each other, and then the last thing that I kind of picked up on was there's a couple little trick questions that I thought some were a little tricky on this test. And there's something that like in engineering that we call intuition that we build. You always want to build your intuition. Um, so sort of like I think of it as a temperature check. So you're sort of just like, does this answer make sense? Like are you in the right ballpark? Is really what you want. So when you do the math and you get an answer, and you're like, is that right? Did I do that right? I'm not sure. If you work on intuition, you can kind of figure out if you're in the right ballpark, and that'll help you with those tricky questions, those sort of ones that can be worded a little weird or whatever. So that's sort of just like the main concepts I kind of wanted to go over, and I think if you can kind of master these, it'll help you a lot on the other ones. But yeah, so let's see. So, right. First question is um, use a proportion or percent equation to solve each of the following. 12.5% of 236 is what number? So this is where I wasn't really sure. So you can think of a percent as a part over a whole is equal to a percent out of 100. So what this is a relationship, right? We're saying this is equivalent to this. So um, this is a relationship between the two. Another sort of way of phrasing it is, um, I'm assuming you're familiar with the concept of using x as an unknown variable. So if you're not, I could sort of go into that more. But it's sort of like this is sort of an equivalent way of saying like what percent out of 100%. Um, so with that being said, I can explain that more if it's not clear. Um, so there's a couple things that I wanted to sort of go over when I don't know if I have a pen in here. Anyways, when you get these sorts of things, these sorts of questions, you can break it down literally, like you're translating the math into uh, words and equation. So when they say is, um, what that translates to is equals to. And then when they say of, or sometimes there's a couple other words that they can throw in there, that equivalates to multiplication, like multiplying. So I'm not sure if you use dots or x as your multiplication. I know if you're familiar with using x as an unknown variable, the x and the x gets confusing. So the higher level math, you'll use the dot to indicate multiplication, but I'm not sure if you use x to indicate multiplication. Um, and I guess this is another sort of basic concept which I'm going to build upon, but really basic algebra rules, right? If you take any number and you multiply it by 1, that doesn't change the value. So if you have 7 and you multiply it by 1, you still have 7. If you have 5 million and you multiply it by 1, you still have 5 million. And it's the same as dividing by 1, right? If you divide by 1, it doesn't change anything, right? So you can take 75, divide by 1, you still have 75. So I'm going to use those two rules, those basic algebra rules, and I kind of like that. This is how my brain works. So I kind of am going to build upon that and go from there. So the intuition that I was talking about, right? So if I asked you, what is 50% of 100, right? I hope it's obvious that the answer is 50, right? Your half of 100 is going to be 50. So the next step is, what if I asked you what is 48.97% of 102.6, right? Well, what you know is, it's not 50, but it's close to 50, So that's sort of the intuition that I'm talking about. So there's some of these questions like 12.5% of 236, right? You can kind of estimate that as 10% of 250 or 200, somewhere in that ballpark. So when you do your math, if you get an answer that's 1,000, you know that that answer is incorrect. So that's sort of like what I think is a useful thing. Um, so yeah, like for example, what is, if you wanted to think about it in your head, what is 19.7% of 97.1? What is that equivalent ballpark going to be? If you want to, I guess you can pause and think for a second. What is 19.7 close to? What is 97.1? So, yeah, so it's roughly 20% of 100. So it's going to be around 20. But, okay, here's another good question, which I'll leave for you. What is 1.6 cups, which is 12.8 ounces in gallons? So this is another intuition-based thing. So if you think about a cup, like a glass cup that you drink water out of, that's about 8 ounces. And we want to convert that to gallons, like a gallon of milk. If you were to pour the water from 1 cup or 1.6 cups, 12.8 ounces, into a gallon of milk, or without any milk in it, into an empty gallon, how full is that gallon now? So that's sort of a good way to start in terms of doing these sorts of problems. So yeah, I didn't want to do your homework for you, but that gives you a sort of a ballpark, right? So 12.5%. Remember what of was converted into is multiplication, and then is equals to, and then if you have whatever the thing is asking for, is what number. So you can use that to hopefully get the right answer. And if you wanted to go through it and work, I can help you answer it. Or if there's more questions about things too, I can answer. Let's see. 196 is... Okay, so this is question number 2. In a recent survey, 196 people said that their favorite color was red. In this number, if this number represents 35% of all people surveyed, find the total number of people surveyed. So This is kind of one of those ones where it's like really wordy, and they don't need to make the sentence that long, but they want to, test your ability to read multiple sentences and pull the equations together. So if you rewrote that as 196 is 35% of the total number of people, right? That's is that not equivalent? Think about it to the first sentence, right? So you could take out the phrase in the recent survey. You said 196 said their favorite color car was red. So you could, we really don't care what the car color is, or what they're talking about. You just care that it represents 35% of the total number of people. So that's that percent out of the whole. 35% is a percent of the total. So, you can use your intuition just from reading and try to get a ballpark of, is the total number of people, what's a ballpark number that should be correct? Should it be larger than 196, smaller than 196? That's kind of, if you can get that, then you should be in a really good place to get these all correct. But intuition is really hard to build, and it comes with a lot of practice and experience. So don't be upset if it's a little bit tricky to kind of figure out just from reading it what the ballpark number should be before you get the actual number. But yeah. Number three, 100 and... So this is another one of those tricky ones. I'm not sure if you use a specific formula for percent increase, but I believe one exists. So let's read the question. A company increased its number of employees from 160 to 170. Find the percent increase. Round your answer to the nearest hundredth if possible. So when you think about it, right? So what they're saying is you have 190 or 170 employees is the number of employees after 160 is increased by what percent? So you're increasing by a certain percent, right? So we're at 160 and then we go to 170. So we're increasing by a certain number, a certain percent, but we don't know what that number is. Um, so later here. So really what they're asking is 10% or 10, right? The number that you increased from 160 to 170, we've added 10 employees. 10 is what percent of 160? Um, that's kind of what they're really asking. There's, like I said, there's a lot of different ways you could set this problem up and write down the equation for you to put in, stick into a calculator and get your math. Um, but I think the easiest way is, I don't know if you've ever seen this formula before, but you have a percent change. This is a common formula for a lot of things, for percent increase, decrease, all these different things. So you have your new number minus your original over your original, all multiplied by 100% gives you your percent increase. So I'm not sure you've ever seen that formula before, but that will also give you your number. And if you do this equation here, you'll see that they should be equivalent. I didn't actually do them out, but I'm pretty sure they are. When you do the math out, they should be the same percent. But it does get a little confusing, like I said, in this formula, because sometimes you have up here, you have like a percent, and they're asking for you for what percent. So there's a difference between a percent. I know this is really confusing. A percent as sort of like a number, as a ratio out of a whole, and then when they say like 5% out of 100%, because they're a difference of like 100. So like if you converted 5% to a decimal, it's going to be 0.05. So it's a little confusing. Sometimes those answers are weird, and that's sort of also where that intuition comes in when you're like, is this really 0.05%? Or is the decimal 0.05 and it's actually 5% out of 100%, right? So it's a little tricky, but I think that's, what else did I got? That's it for number three. Um, hopefully that helps you get that guy. It's a little bit tricky. Okay, so we're on to conversion of units. This is where that really basic algebra rules of dividing by 1, multiplying by 1 is going to be potentially helpful here. So let's see, we've got convert the following units. Express your final answer as a fraction or mixed number in lowest terms if necessary. Yeah, we can go over converting fractions if you need to help reducing fractions or simplifying to the simplest least form or whatever. We could do things like that. But for now, I guess let's keep moving on. So 13.5 pounds to ounces. And it gives you the conversion of 1 pound is 16 ounces. So when you think about this relationship, 1 pound, they give you this, right? 1 pound is equal to 16 ounces. What's that equivalently is sort of saying is, is this here, is 16 ounces. You could divide by 1 pound. So since this is equal to y, that means they're the same number, right? They're the same value. X and y are the same value. You could do x divided by y if you chose to put x and divide x by y, because it doesn't really matter what number they are, what the value is, whether it's ounces, pounds, right? You have x divided by y. Because they're the same number, anything divided by itself is equal to 1. And that's what I did down here, is I did 16 ounces divided by 1 pound is equal to 1. So I hope that's clear. So when I go about solving these problems, right, remember when I said we have 13 point, oops, wrong. We've got 13.5 pounds, right? And how I like to do these problems is I like to set it up as just a big fraction, because it makes canceling units super easy. And when you get to really complicated engineering and stuff, you get really crazy unit conversions, and it's always like the last point on a really big test, and it's like they always trip you up and you miss the units at the end. But anyways, so remember what I said, we can divide by 1, right? We've got 13.5 pounds, doesn't matter what it is, it could be X, could be whatever, but we have 13.5 pounds. I'm going to divide it by 1 because we're not changing anything. I like to divide by 1. And let's multiply it by 1, right? We can multiply it by 1, and that's not going to change anything, right? But instead of 1, what if we did, let's replace this 1 with that 1, right? So what we're saying is we have 13.5 pounds divided by 1, multiplied by 1, but what we actually have is 16 ounces divided by 1 pound. 1 pound. So that is our conversion, right? So then you can multiply that out and your units cancel, and there you go. That's how you get your answer to ounces. So that's how I like to think about it. Yeah, I'll let you do the rest. And I guess part C is a little tricky, but it's just the same concept. It's just, you have x over 1, you have, whatever your variable is here, and then you're just going to have another variable like that, and you're just going to multiply it all through and have all the units convert. And that's how you go about it. But I'm not sure how you've learned this, so I hope nothing's more. I hope I'm not more confusing what I'm trying to explain. So number 5, this one is they make it a little tricky too. Express your final answer as a mixed unit in pounds and ounces. So we're converting between pounds and ounces to pounds and ounces. We're just subtracting the two. So the tricky part is, so let's say you were doing this subtraction problem, 37 minus 29, right? How would you do this, right? So you can see that, if you learned subtraction the same way I did, which I'm not sure if they're still teaching you the same way, but you take from the tenths or whatever this place is. Um, so then you're gonna subtract 10 in a way. You make that a 2, and you add 10 down to here, and then because 7 is smaller than 9, you can't subtract 9 from 7 without going into negative. Um, so what you do is you borrow from the tens, you take a 10 out of it, you stick it in the tenths column or whatever. So you have 17, then you have 17 minus 9, and that's 8, and then the 2 minus 2 becomes 0, and your answer is 8, right? So it's a similar concept here, right? So if you have 17 pounds 4 ounces, right? You could subtract 17 pounds and 5 pounds, and you'd get 7 pounds. But you have 4 ounces, and you're trying to subtract 7 ounces. So it doesn't quite. It's the same concept. Like you're gonna go negative. So what you could do is the same concept. Let's borrow from the pounds, and we're going to add to make the ounces larger. So we have 17 pounds and 4 ounces. We know that the unit conversion is 1 pound from above. What was that question? 4a. We know that 1 pound is equal to 16 ounces. So if we had 17 pounds and 4 ounces, we need to first convert that to this. We need to go to 16 pounds. And the question for you is, how many ounces? Because we have originally 4, and we're pulling from that pound, right? So we're subtracting 1 pound, and we're taking that, and we're adding it to that to get that number. So I'll let you do that. If it's not clear, you can let me know. I just don't want to give you the answer flat out. But yeah, I basically gave it to you flat out. But that's how you would do it. Basically these are the same concept now. So you had 17 pounds 4 ounces, and you could convert that to this number here, the 16 pounds and 20 ounces, and then you had the 5 pounds 7 ounces, and you just subtract them like you normally would, and now everything is larger than the other, and that's how you get your answer here. Will be down there. So yeah, I tried to keep it short and sweet. I was hoping we could be more interactive, because I think that's much more valuable in terms of learning. Is when I wanted to have you sort of work through these problems as well. We can work through them together, and I can make sure you're on the right track and you actually get them yourself with my help. But yeah, hopefully this was helpful. I'll send this over to you, and I guess if you have other math questions, like, you can always feel free to reach out. It's not a big deal for me to give you a little bit of help. So everybody needs help from time to time. I had math tutors all the time growing up. So yeah, I'll stop the recording, and hopefully this helped. And let me know if something didn't make sense. I can go more in depth about a topic. If I need to scale things back, be simpler, I can do that as well. So just let me know. All right, bye.